In this video, we are going to discuss about the maximum power transfer theorem. It helps us to find the values of load resistance for which the maximum power will be transferred to the load. It is a useful tool for designing circuits that need to transfer maximum power from a source to a load. It is also used in a variety of applications such as solar power system, battery chargers, and audio amplifier. The power transfer theorem is used in electrical circuits, or it is not used applicable in the power system. The maximum power transfer theorem can also be implemented to linear networks, that is the network which consists of RLC. The maximum power transfer theorem functions only when there is a variable load, that is RLS should be varied. If not, choose the least available internal source of impedance, which will pay maximum current through fixed load. Consequently, the maximum power is expelled by the load circuit. Large sound systems are built around this process. The maximum power transfer is generated in the circuit by making the speaker load resistance equivalent to the resistance of the amplifier. So once the amplifier and the speaker have equal resistance, both are considered harmonized. So it is also used in the application based on relation between the starter motor and the battery of the car engine. Power applied to the starter will be rely on the actual resistance of the motor and battery resistance. When their values are equal, highest power will be transmitted to the kickstart the engine. So let us discuss the maximum power transfer theorem problem. Before that, so the maximum power is get transferred when the source resistance value is equal to the load resistance value, that is RTH is equal to RL. So let us prove that condition first. This is a VTH value and this is a RTH value, and this is a changeable resistance, which is the load resistance RL. Okay, so I need to find the current across this one. So if I want to find the power to this load, I can write the power. What is the power formula? Power is equal to I square RL. So in order to find the value of I is equal to VTH divided by RTH plus RL. The voltage across this one plus this divided by this resistance. So I can substitute this one, VTH by RTH plus RL whole square divided by R. So this I can write it as VTH square divided by RTH square plus RL square plus 2 RTH RL into R. So divide RL on both sides. So you'll get VTH square divided by RTH square divided by RL plus RL plus 2 RH. This is nothing but power. Okay. So in order to get the maximum power, I need to differentiate dP with respect to RL and equate it to 0. So I am going to equate this whole function. See here in the numerator I am not having any RL. So I am going to equate this denominator alone. So if I differentiate this denominator, RTH square divided by RL plus RL plus this one is 2R RTH, right? to 0. So if I differentiate, so I can write DRL RTH square RL minus 1 plus RL plus 2 RTH, that is equal to 0. Right? So if I differentiate this one, I will get minus RTH square RL square plus 1 plus 0, that is equal to 0. So you will get RTH square divided by RL square, that is equal to minus. So RTH square is equal to RL square. Therefore RTH is equal to plus or minus RL. So the maximum power will deliver only when the Thevenin resistance that is equivalent resistance of the given circuit that is equal to the load resistance. So now let us discuss on problem on this. So consider this is my circuit. Okay. So before that, so if we substitute this value here, okay. So if I substitute this, the RTH is equal to RL in this value, I will get VTH divided by 2 RTH whole square divided by RTH, right? So that is equal to, so the P max value is equal to VTH square divided by 4 RTH. This is another important formula. Okay. So let us discuss on problem on maximum power transfer theorem. So to find RTH. So to find RTH, the source voltage source must be short circuited, and you have to remove the RL. The RL must be removed, right? So if I remove, I will get 1K, 1K, and 1.5K. So here only we need to find the value of RTH. Okay. So what is the value of RTH? RTH is equal to, this is 0.5 and this is 1.5. So you will get 2K, right? RTH is equal to 2 kilo ohm. So now to find VTH. Okay. And this is why VTH. So there is no use in connecting this resistor here, because the current flowing through this one is 0. Since it is open circuited, the current flowing through this one is 0, because the current will not flow in the open circuit area. So all the current, that is I, will flow only through this resistance. So I can write these two resistors are in series. So the resistance value is 2K. So VTH is equal to 10 divided by 2K. That is nothing but 5. I is nothing but 10 divided by 2K, that is 5 milliamps. Okay. So the voltage across this one is nothing but that is nothing but VTH. Okay. So voltage across this one is 5 milliamps into 1K. That is 5 volt. Okay. So I have find out the Thevenin's voltage and Thevenin's resistance. and this is nothing but RL. So what does the theorem says? The theorem says is when the RTH value is equal to RL, you will get the maximum power. Maximum power will be delivered. So consider this RL value is something but 2K. Okay. So if this is 2K, okay, so you will get maximum power will be delivered. So what is the value of I? I is equal to 5 divided by 4K. That is nothing but 5 divided by 4 is 1.25 milliamps. So 1.25. So I can square this value and I have to multiply it with 2K, right? So you get the power as I square RL. That is 1.25 milliamps square into 2K. That is nothing but 3.125 watts. We'll get the US. Okay. So what happens when R? This is the first value, right? So what is the value now? If VTH is equal to 5 volt and RTH is equal to RL is equal to 2K, and therefore the power value is equal to 3.125 milliwatts. Okay. So what happens when RL is equal to 1K? Okay. If RL is equal to 1K, I will get I is equal to 5 divided by 3K. Right? So what is 5 divided by 3? 5 divided by 3 is 1.666 milliamps. So the power is equal to 1.66 milli into 40K. So that is nothing but 2.77 milliwatts. Okay. So if I choose 1K, you will see the power get decreased. Okay. So if I choose when RL is equal to 3K, okay. If I choose RL equal to 3K, I will get current. Current is equal to 5 divided by 5K. So I will get 1 milliamps. So what is my power? Power is equal to I square RI. That is nothing but 3 milliwatts. 3 milliwatts. So if I choose for 5 volt, if I choose this one as 3K, I get the power as 3 milliwatts. If I choose the RL value as 1K, I'll get power as 2.77 inwards. So if I plot a graph between this power and RL, we will get the maximum value only at RL is equal to RTH. And the rest of the value, that is here RH value is something but 2K, right? It is 2K. So when it is 3K, you can see the maximum value at this point is 3.125. Okay. So at 3K you will get 3, right? At 1K you will get 2.77. So you can see the power get reduced before and after the values of RTH. Get it? So instead of this 3 value, you can take nearly 15 values and you can plot this graph. So if you want to find the current at this point, you can connect a meter here and can find the value of current.